Hi, I'm Adolph Oliver, and this is the video about one-line word problems that are solved by quadratics. Actually, not all of them are one word, one line, but they're simple, and most of them we look will be that. So again, if there's a squared term, these can be solved by quadratic methods. So let's take a look at what we can do here. The first one of these says the product of page numbers on two facing pages of a book. So you know if you open a book up and look at the two pages, this would be like page 11 and this would be like page 12. So here's the idea. The first page, we could make, let's just say our page number, let's say N. The second page will be one more than that. So it's going to be N plus 1. Okay, well, we've defined how we're going to start this. You could use different variables, but this works good. Now it says the product of these page numbers is or equals 110. So N times N plus 1 equals 110. Well, okay, let's multiply out the left side. We've got to get rid of the parents. N times N is N squared. N times plus 1 is, well, plus 1n. Since this is a quadratic, let's jump the 110 over. So minus 110 equals 0. Okay, well, here we go. It's going to be a nice little reverse FOIL because we have a plus 1 in front of the n squared. So what I want is two numbers, okay, that multiply together, give me 110, whose difference, the minus here reminds us we want difference. Remember, if that was plus, it means we want sum, but it's a minus, so we want difference equals 1. Well, this is not too hard. What two numbers multiply together give you 110 whose difference is 1? How about 11 and 10? Now, since you have a minus on the last term, that means the signs are one of each. So we can factor this directly. Let's say n minus and n plus. And of course, we've got our 0 over here. So there we are. We're all ready to go. Well, we got to be careful we get everybody in the right spot. So when the signs are different like this, you always play the bigger game. 11 is bigger than 10. The bigger guy has to have the sign of the center term. So the 11 goes behind the plus wherever it is. I put it there. And the 10 goes in the other hole. Okay, here we go. The root we get from n minus 10 is 10. The one we get from n plus 11 is negative 11. Well, page numbers in books aren't negative, so our n is 10. Now, don't stop here, because what this problem asks for, find both the page numbers, and the best place to label these is right up where you define your variables. The n we said is 10, and the next one here, 10 plus 1, will be the next page, 11. So there are the two page numbers, 10 and 11. Well, these guys are nice, simple problems. Let's take a look at another example of a type of problem you can run into. Here we go. We've got the product of two consecutive even integers is 28. Excuse me, 288. So now we want two even integers. Now, they'll come out correctly, even or odd, depending on this information that we've been given. So we just take that at face value, and we'll see that it works out in the tail end. Okay, first integer. Okay, let's make that equal to x. Use whatever variable you want. Now, these are consecutive evens. So the next one is the next higher number up. But if this is even like 4, the next even would be like 6, which means it jumps by 2. Even and odds all jump by 2s. Odds 3, 5, and 7 jump by 2s. Evens 2, 4, and 6 jump by 2s. So that means our second integer, okay, equals x plus 2. Now, once again, the product of these two. So I'm going to take x times x plus 2 equals, what did they say, 288? Okay, well, let's clean this up. X times x is x squared. X times plus 2 is plus 2x. This is a quadratic, so I'm going to jump the 288 over. It'll become minus 288 equals 0. Okay, this is going to be a nice little reverse FOIL again. The minus sign right here means the signs are going to be one of each, not uncommon in these problems. But here we go. We want two numbers, okay, that are just, see, minus here means the difference is two numbers that are almost the same. They're just two apart. Well, okay, let's see what we might do with this. Again, if you had your calculator handy here, you could take the square root of 288, and that'll get you started about where you're going to go. But let's take a stab at this just looking at it ourselves. 15 times 15 would be 225. So this is going to be higher than that. 16 and I think maybe 18. Let's give this a try. 16 and 18 multiplied together. Now, why I thought of this was I know 6 times 8 is 48, and that matches the 8 here. Let's see if I'm correct. 6 times 8 is 48, carry the 4. 8 and 4 is 12. And then we have the 16, yeah, 288. So that's good. So here we go. We're going to factor this into x. Let's say I feel like putting a plus here, and x, I'll put the minus there. Just be sure again, you got signs, one of each. Well, okay, the numbers we got were 16 and 18. We have to play the bigger game, so the 18 has to go with the plus. Okay, well, I put the plus here, so there's the 18. The 16 goes in the other hole. Now, I get from the x here negative 18, and I get from the x here positive 16. Now notice in this problem, these are integers. Integers can be both positive and negative. So what we're going to get are two possible answers here. First, for x equals negative 18, remember that's one of the values we got down here. This will be negative 18, and negative 18 plus 2 will give me negative 16. So there are two integers that are consecutive evens. But x equals 16 also works. So here it is. I could say, okay, x equals 16, and then x plus 2 would be 16 plus 2. That means this guy would be 18. So you got two possible answers here, and you got to indicate them both. Negative 18 and negative 16, and 16, positive 16 and positive 18. Okay, well, let's look at another example down here. Okay, here's a problem where we have the product of two consecutive integers is 3 less than 3 times their sum. Find the integers. Okay, two integers again, so we'll say the first integer, okay, let's use n this time. You could use x again if you wanted. Consecutive, okay, now notice they don't mention even or odd here, do they? So if it's consecutive, it's one after another. So if this is n, the next one, it's just going to be n plus 1. So always be thinking carefully here. Consecutives just follow one after another, you know, 12, 13, 14. Consecutive, even, and odds jump by 2. Okay, so this is going to be n plus 1. Okay, so such that the product of these, okay, here we go, n times n plus 1, there's the product, is, remember we can replace this with equals, so that's where our equals sign goes, so here it is, 3 less than 3 times their sum. Well, what's the sum of these going to be? N plus 1. Okay, if we take the sum of these, and we're supposed to have 3 times that sum, here it is, and it's going to be 3 less. Now remember, be careful about this subtraction. We're subtracting 3, but the whatever you subtract always follows the minus sign. Remember again that subtraction does not commute, so you have to be careful with it. Well, let's clean this up a little bit. The left side here is n squared plus n. Over here, if I add these guys together inside the big set of parents, I get 2n plus 1. So if I distribute to 3n, I'm going to get 3 times 2n, which is going to be 6n. And 3 times plus 1 will be plus 3. And oh, look at this, we had the minus 3 here. Okay, well, we got to combine these like terms. So I've got n squared plus n equals 6n and plus 0, so I don't need to write that down. This is a quadratic, so I'm going to jump the 6n over to the left to get the 0 on the right. This comes over as minus 6n. So I got n squared minus, well, let's see, negative 6n plus 1 is negative 5n equals 0. Well, this is real easy to factor. We just factor out the GCF here, which happens to be n. So I get n times n minus 5. Okay, here we go. Well, what are the values? Okay, this guy, of course, right here gives me positive 5, but what value of n makes n 0? Well, n equals 0. Okay, so once again, we get 2 possibilities. Remember, these are integers. So if I turn around and use the n equals 0, okay, of course the n will be 0 here, and 0 plus 1 means this is 1. So 2 consecutive integers that solve this are 0 and 1, but n equals 5 also works. So there's a second set of answers. N equals 5, and 5 plus 1 equals 6. So here we go. Once again, you've got 2 different sets of answers you've got to quote. Okay, 2 consecutive integers that will solve this are 0 and 1, but another set that will solve it are 5 and 6. Okay, well, see, we sometimes get more than one set of answer on these. Let's take a look at some things that are getting maybe a little bit more involved here, but still very doable. The product of 2 consecutive odd integers. Well, okay, once again, first odd, okay, let's make it x. You can make it n, whatever you want. Second odd, now remember, evens and odds jump by 2's, so this is going to be x plus 2. Okay, we want to take the product of those, so x times x plus 2 equals, this is where the equals can go here, okay, 77 more than twice the larger. Well, here's the larger, so I got to take twice the larger, 2 times x plus 2, 77 more means I've got to add 77. Okay, let's clean this up again. X times x is x squared plus 2x equals, well, over here I've got 2x, 2 times plus 2 is plus 4, and then plus 77. Well, these are like terms, so we got to combine them. So I got x squared plus 2x equals 2x. And what do we got here? Plus 81. Okay. Well, now, since this is a quadratic, we want to move everybody over to the left here. So here we go. The 2x comes over as negative 2x. The plus 81 comes over as negative 81. So what have I got here? Well, I've got x squared. But notice, plus 2x and minus 2x zero out. So I have the minus 81 equals 0. Well, remember the difference of two squares? The square root of x squared is x. The square root of 81 is 9. And since we have the required minus, this factors into x plus 9 times x minus 9 equals 0. Okay, well, we get two roots here. I'll have to write them over on the side here. X plus 9 gives me negative 9. X minus 9 gives me positive 9. Okay, well, once again, since this is integers can be positive and negative, we get two answers here. So for x equals negative 9, the x, of course, is negative 9. The second one is negative 9 plus 2. That's what, negative 7? So there's one set of the answers. But we also have to make use of the plus 9. So x equals plus 9. Well, the x is just plus 9. The x plus 2 would be 9 plus 2. This would be plus 11. So once again here, two sets of answers because integers can be positive or negative. Negative 9 and negative 7 work, and plus 9 and plus 11 work. Okay, one last guy to take a look at here. Find three consecutive integers. Well, okay. And consecutive integers now, no evens or odds. So I could say first integer, okay, let's make it equal to, well, let's go back and use n just for fun. Second integer, okay, is going to be one more than that, so n plus 1. Third integer, okay, is going to be one more than that last guy, so he's going to be n plus 2. Okay, there they all are. Okay, so now such that 3 times the sum of all three equals the product of the larger two. Okay, 3 times the sum of all three. Well, first off, if we sum them all up, I'm going to have n plus 1 plus n plus 2. Got to add all these guys up. So I put them in big pairs, and they said 3 times this sum equals, and they actually got the word equals here. There we go. The product of the larger two. Well, here are the larger two. So n plus 1 times n plus 2. Okay, well, a little bit more involved, but, you know, once you lay out what the integers are, n plus 1, n plus 2, the rest of it here is pretty straightforward. So let's go ahead now and clean this up. This big set of pairs, I can just add these up right now. I'm going to have 1, 2, 3 n's, okay, and then plus 1 plus 2 is plus 3. So this is going to be 3 times 3n plus 3 inside here. 3 times 3n is going to give me 9n. 3 times plus 3 is plus 9 equals. Now over here, we're going to FOIL this guy. Okay, multiply the two first together, I get n squared. Multiply the two last together, I get plus 2. Do the two rainbows to get the O and the I of FOIL. The big rainbow is plus 2n, the little rainbow is plus 1n. Well, this is plus 3n. So here we go, we've got n squared plus 3n plus 2 on the right side. Well, okay, this is definitely a quadratic. There's a squared term. What I'm going to do is I like to have everybody on the left. If I jump the n squared over by itself, it'll become negative. So I don't want that. That'll goof up my factoring. So instead, what I'm going to do is interchange the sides here. So we're going to have n squared plus 3n plus 2 equals 9n plus 9. Okay, these two individual guys have to come over to make a 0 here. So let's clean this up further. N squared, the plus 9n comes over as minus 9n. So minus 9n plus 3 is negative 6n. And the plus 9 comes over as minus 9, huh? So let's see, minus 9 plus 2 is what? Minus 7. equals 0. Okay, this is a nice little reverse FOIL here. We've got our n squared with a nice 1 in front of it. So what I want are two numbers that multiply together to give me 7. Well, not a whole lot of choices. The difference of these has got to be 6. Good thing, because 1 times 7 is the only thing I can do here. And 1 times 7 is 7. The difference is 6. So that's definitely our winning combination here. Now, once again, the signs are one of each here. So it's going to be n plus somebody times n minus somebody equals 0. Okay, well, when the signs are different, we have to play the bigger game. 7's bigger than 1, and it has to go with the minus. It matches the center term. So 7 goes behind the minus. The 1 goes in the other hole that's left. And here are the two choices that we have. I can squeeze it in here. N equals -1, and n equals +7. Well, again, since these are integers, they can be positive and negative. So once again, we're going to get ourselves two sets of answers here. So if I use the n equals -1 I got, okay, that means the first integer is -1. I add 1 to that to get the second guy. That gives me 0. I add 1 to that to get the third guy, and that gives me +1. Now, likewise, if n equals 7, that's the other possible answer we got here. So the n is in 7. The next guy I add 1 to, that means 8. The next guy I add 1 to the last guy, that means 9. So once again, here we go. I've got two sets of answers that will solve this. Here they are. Okay, -1, 0, and +1. Also 7, 8, and 9 will do the job. Okay, well, this has demonstrated a number of word problems. You know, a lot of them dealing with integers or page numbers or things like that. But again, translating them carefully, the key is make yourself a list to begin with of what you're going to name each of these guys. You know, first integer n, second n plus 1. And this is also the primo place at the tail end to indicate what your answers are, because of course that's what the problem asks you to do.